Welcome back to All This Math. This is Professor Parker. Please, if you're here, go ahead and hit the like button. Also, subscribe to the channel if you haven't already. Also, share this video when we're done. When you're done watching it, go ahead and share it with somebody, at least one other person. And if you have any questions or comments, please put your questions or comments in the comment section. All right. I also want to give a shout out to Xavier University. Somebody told me it was pronounced Xavier. I think I was pronouncing it incorrectly. I guess it's according to who you ask. I was pronouncing it Xavier, right? Down in New Orleans. You know what I'm saying? Shout out to the historically black college. But I promote all HBCUs. So, Xavier University is one of the HBCUs in Louisiana, one of several. All right, now let's get into this problem. Now, today we are dividing rational expressions. Rational expressions. We're dividing because you see the division sign right there, right? Excuse me. What makes these expressions rational? The fact that they're set up like fractions, right? That's one way to look at it. So if you have a expression that's set up like a fraction, that's also known as a rational expression, a rational expression. All right. Now, how do we do this? Now, for many years, I always, when I did problems like this, like when I learned this back in like either middle school or high school, this is like algebra one, really, right? But you might see this in a college algebra class because for real, college algebra is really like algebra one for real. Might have some algebra two topics, but it's really algebra one, right? Just rebranded, boom, slap a new name on that joint. You know what I'm saying? Let's call it college algebra now because we're doing it in college. But it's just algebra one for real, for real. So keep that in mind. But when I was in algebra one, like in middle school, um, I used to always do the keep, change, flip thing. So I would keep this first rational expression the same. I would change the division sign to a multiplication sign, and then I would flip this second fraction or take the reciprocal of the second fraction or rational expression. The denominator would go up top, the numerator would go down the bottom. But actually, then I later learned, years later in life, during my teaching career, that you don't even got to do all that. You can actually divide horizontally. We can divide horizontally. We can actually do that. All right, now what are we gonna do though? But let's look at this though, right? Let's look at this first rational expression, and let's see if we have anything that's in the numerator and in the denominator that we can divide out, right? I see a 2x minus 1 up top. I see a 2x minus 1 down the bottom. So we can divide them out. Boom, boom. They turn into ones because anything divided by itself, whether it's a single number, single variable, a binomial, a trinomial, right? If you're dividing something by the same exact thing, the quotient is going to be 1, or they turn into ones, right? So that's what we got. Now, x plus 4 up top, x plus 8 down the bottom, x minus 7 up top, 3x x minus 4 down the bottom. So nothing on the top and bottom. But now let's look horizontal, right? Let's look horizontal. I got an x minus 7 right here and an x minus 7 right here. Now we can divide horizontally. So x minus 7 divided by x minus 7 is going to be 1. So they're going to turn into ones. My bad. That looks like a minus sign. Let me get that out of there. All right. Then I got an x plus 8. Look what we got down here. I got an x plus 8 and an x plus 8. Right? And then I got a 3x minus 4 and a 3x minus 4. Right? Now, what's left? What we got left? In the denominators, we got 1 times 1 times 1, which is 1, divided by 1 times 1, which is 1. So we got 1 divided by 1. What's left in my numerator? X plus 4. That's a 1, that's a 1, and that's a 1. I got x plus 4 divided by 4x minus 3. So I got this. I got x plus 4 divided by 4x minus 3. Now, don't worry about the denominator. Where the denominator at? The denominator is just 1, right? What happens when your denominator is 1? When your denominator is 1, you don't got to write it. It's understood, just like the number 7, right? The number 7 can also be represented as 7 over 1, right? So meaning you don't need that 1. When 1 is your denominator, you don't got to write it. You don't got to write it. When 1 is your denominator, you don't got to write it. All right, so that's what the situation is here. Even though we're dealing with binomials and we got variables, that principle stays the same. It don't change. It don't switch up. All right, so now we got x plus 4 divided by 4x minus 3. So I'm going to just rewrite this in vertical format with the x plus 4 as my numerator, right, which is my dividend. My dividend and numerator are the same thing. My denominator and divisor are the same thing. So the x plus 4 is going to go on top, and the 4x minus 3 is going to go down the bottom, right? That's what I'm left with. Now, let me say something to you. Let me tell you what you can't do, what we're not about to do. This x cannot divide by this x. That's a rookie mistake. That's Bush League. We don't do that. And somebody would try to do that. This x cannot divide by this x because this x is part of a binomial. It's part of x plus 4. You can't just go in there and take out a piece of that and go in here and take out a piece of this. This 4x is part of 4x minus 3. So we can't do x divided by x. We can't do that, right? That's against the rules that we accept for mathematics and the rules we accept for algebra, right? We don't violate the rules, right? We got to have rules. If we don't got rules, we don't got nothing, right? And then we can't divide this 4 by this 4 because this 4 is part of x plus 4 and this 4 is part of 4x minus 3. So therefore, there's nothing else for us to do. We can't simplify this. We can't factor this. We can't factor that, right? Because the only factors would just be positive 1 or negative 1. So we done. This is our final answer. But what I want to reinforce is this idea that you don't always have to do keep change flip. I like keep change flip. I like doing it. I like using it. It's cool. Like, you know what I'm saying? Like, but you don't always have to use it. But if we did do keep change flip, we would have ended up with the same answer. We'd have ended up with the same answer. Because look, the 2x minus 1s are still going to cancel out, right? If we flip this, the 3x minus 4 would have been on top. It would have cross canceled with that 3x minus 4. The x plus 8 would have still cross canceled with that x plus 8. The x minus 7 would have went down the bottom. It still would have cross canceled with that x minus 7, right? And we still would have ended up with x plus 4 on top. And this 4x minus 3 would have went down bottom. And that's what we would have had. So that's just proof that, like, you know what I'm saying? Like, you can divide horizontally. You can divide horizontally. We can do that, right? We can divide horizontally. That's the main point that I want to make. That's why, that's part of the reason I did this problem, because I wanted to have that conversation with you, that you can divide horizontally. All right. So dig this, right? Make sure that you hit the like button, right? I don't remember if I told you that when I started the video, but anyway, yeah, please hit the like button. I mean, you here, right? Go ahead, hit the like button. Don't be a hater, right? Subscribe to the channel if you're not subscribed already. If you got any questions, if you still got questions about anything I did, that's cool. I like questions. I welcome questions. I like that, right? Please put your questions in the comments. Put your questions in the comments. Put your comments in the comments. All right. And what else I want to say? Oh, yeah, share the video. Share the video with at least one other person. Somebody taking an Algebra 1 class, somebody taking an Algebra 2 class, somebody taking a college algebra class, one of the HBCUs or even one of the HWCUs, or historically white college. They can get love too. You know what I'm saying? The students can get love too if they need the help. All right. But yeah, go practice these dividing rational expressions. And remember, you can divide horizontally. You can do that. You can divide horizontally because I showed you we would get the same answer. We get the same answer. If you did keep change flip, you would get the same answer as if we did keep change flip. So that's proof that we can do that. All right. See y'all later. Peace.